Good day. Today is 27 September, and we are reviewing the item analysis for your first attempt of the Module 1 assessment. There were 7 completed attempts. Only one student failed to log the first attempt before the cutoff. The average score was a 3.8 on a 5-point scale. That's a 76. That's actually a pretty fair standing considering it's a first attempt of assessment for new material in one of our newest courses. According to the difficulty rubrics for Blackboard, Blackboard algorithms determined that there were 8 questions of medium difficulty, 9 that were easy, and 1 that was hard. The discrimination, which again does not account for mastery learning, there were 3 where we could not calculate whether or not it was considered to be a good question, a fair question, but that could be because students answered everything correctly or answered everything incorrectly. We'll find out shortly. We'll go ahead and update our participants list. Good morning, Jadel. How are you today?
Good morning. Doing great. And you, Professor Kentop?
Not too bad. Do you have time later today to allow me to get the virtual hard disk from your machine so that we can stage our provision of the virtual machine we started to build in our last hands-on on Friday?
Sure thing, yeah.
Okay. How about 2 o'clock?
Oh, 2 o'clock? Perfect, yeah.
Okay. I could do it sometime before 1 o'clock, but I got to have enough time for that thing to copy over. And I will be in the office sometime between 11 and 1. So we want to pass the baton for that, okay? All right. So let's sort by average score. So a multiple choice that's worth a quarter point. These are the ones that everybody got correct. So to answer our question, the 3 questions, the 3 assessment items that the algorithm couldn't determine whether or not, there was appropriate discrimination by students and whether or not it was a good question or a poor question. It's because all the students answered correctly for those 3 items. We won't spend any time reviewing those. But if we sort by average score, and this is where we're going to make sure we keep a record of this. Let's go landscape. Let's go minimum margins, headers, footers, background graphics. All I'm doing is keeping a printed record here of the assessment outcomes for Module 1. This is our item analysis. This is something that we use later on to refine our course material. So that's what I'm doing right now. Let's take a look at each of the items that posed the greatest challenge for students, all the way down to well, most everybody got these correct. When you see 0.22, that's nearly everyone because those are 0.25, except for the multiple answer. So we aren't gonna cover all of the multiple choice that are 0.22 average scores because only one person got those wrong. And we did have one person that was rushed and had a very low score. I think they were trying to get in before the deadline. So we're going to treat that as an outlier. The TCP/IP protocol suite is sometimes referred to as the Department of Defense model. This is listed in the textbook. It's stated verbatim in the textbook. The 5-layer internet model was derived from the TCP/IP protocol suite that was developed under the ARPA project, right? The Advanced Research Projects Agency, when in the early days of the internet, so there was a 4-layer model. The 5-layer internet model was eventually developed by industry partners for folks who implement and manage networks, not by those who conduct research and devise standards for the networks, the IETF. So the 5-layer internet model was something that took the 7-layer OSI and collapsed it down to 5, because most people who are implementing and supporting networks in industry in the workplace are not developing applications, and therefore the 5, 6, 7 layers of the OSI model are less relevant for them. I mean, it's still important, but I hope that explains in greater detail what's going on here. Are there any comments, observations, questions about this item in particular? Remember, what's in the textbook counts. There will be questions from material right out of the textbook, even if it isn't in the study guide, okay? Everybody understand? I need to get an amen from someone.
Amen.
Okay, thank you. So, oh, by the way, Akeem, I'd like to share something with you after class regarding internship. I did forward materials onto the worksite, and I'd like to follow up with you, just a brief conversation, okay?
No problem.
Okay. So this next one that through students, 3 of 7 students, reads a recommended measure to eliminate the use of NetBIOS over TCP/IP is to disable the magic packet option on the hardware interface. It is true that we want to disable the magic packet option of the hardware interface. However, I want you to understand the magic packet option on the hardware interface has nothing to do whatsoever with the NetBIOS over TCP/IP setting. Those 2 settings are completely unrelated. This has to do with the hardware as it relates to automatic power on from a distance. That's a totally different thing. That's physical. That's a magic packet. It's like a wake-up packet. It has to do with power save settings. This has to do with an old, deprecated, or retired protocol that has all sorts of network exposure we don't want running on top of TCP/IP, okay? So this one's layer 3, this one's like first layer, second layer, 2 totally different issues. So it helps to think in layers. When you're seeing a question like this and you have doubts, go back to the models, the network models, and that may help with discernment. Any questions about this item in particular?
No questions.
Okay. Let's update our attendance roster. Good morning, Shanoa.
Good morning.
So another item that posed a challenge for students. We made mention of this in class several times. I did not explicitly relate in the study guide, or it's not in the textbook either. But I mentioned it more than once. I said there's a switch or an option for NetStat that allows you to list the associated executable for a network socket. So instead of NetStat A, where it shows the connection sockets on both sides, it shows the local socket and it shows the remote socket. That's what A does. NetStat-B shows the executable associated with a network socket. If you opened a command prompt and then typed /? with netstat, or looked up netstat help for options, this one would jump out and kind of bite you on the nose. So there were a couple of students that missed that. This one is the one we use all the time to list the complete connection for the session. So a session is defined by two network sockets, the one on the client side and the one on the server side, separated by a comma. And this is out of the study guides from CSC443. Does anyone want to review that information at this time, or does everyone know what I'm talking about? You have a client side connection with an IP address and port number, right? So a socket is an IP address with a port number. Everybody understand what I'm saying there? Socket is a port number with an IP address. You have a client side socket, you have a server side socket. The two of them separated by a comma is what you need to define the connection. Yeah. Did we lose audio?
No, I think we get it
Okay.
with the netstat B.
Okay. All right. This one posed a challenge, and I almost included a picture of this provocative GRC shields up scan, but I would like to ask the student if it's okay. I'm going to anonymize the thing, but I don't want the student freaking out because it's like, oh, that's my GRC shields up. I'm not going to attribute it to any student or any service provider, but you discover multiple streaks of blue in a GRC shields up scan. However, the client used to perform the scan shows all green when connected to all other networks. So when you take that same client and connect that same client to any other network, it's smooth, fast, and hot. Everything's green, everything's secure. What is the most likely cause of this scenario? And the correct answer is other clients that are connected are causing this. So when you're doing the GRC shields up and then you turn up or down the firewalls in succession, right? So you turn off the firewall on the local client. That's one level of unshielding. And then you turn off the firewall at the router. That's the second layer. You're likely seeing those blue streaks because the router firewall is the one that's picking up on the other unshielded ports for other devices. Does this make sense? I could do a deep dive on this on Friday if someone would like. If that statement is even mildly confusing, I'd like to explain further on Friday with the whiteboard. Is there any interest in that explanation for members of the class this Friday? Yes, no, maybe? Or does everybody get it?
Yeah, you can.
Okay. We will take a little time on Friday to explain that. Please remind me on Friday, okay? And remember, Friday is our hands-on day, right? Okay, DNS utilizes. This is a multiple choice question. DNS utilizes which layer 4 protocol and port in order to function? Now, this is one that can sneak up on folks. So when DNS is being used to resolve names for browsing on the internet, for communication applications, right? So for messaging applications that require name resolution, when DNS is providing that service and it goes out to query on behalf of clients to the root servers and then the top level domain servers and then the primary domain servers and so on, right? That's called recursion. When it goes out to the root servers, then it goes out to the top level domain servers, and it goes, that's what a DNS machine does. It's an iterative process. That's when it's giving answers to clients, it's using UDP. But when it's talking to other domain name servers, when it's talking to other DNS servers, it's using TCP port 53. So the front side of the name resolution service that's helping clients, connected clients in the neighborhood find naming, to find named resources, that's UDP. So all of the connected clients in the local neighborhood are saying, hey, where do I find Amazon.com or uvi.edu? And the answer that comes back from that DNS server to the client on the front side with clients, that's UDP port 53. But when that DNS server has to serve up primary zone records or request those from other DNS servers, it's TCP. So it uses both. It has to use UDP for name resolution and 53 for zone transfers and for recursion. The process, now I didn't put recursion, but when a DNS server is providing records of where to find what to other DNS servers, oftentimes there are zone transfer updates in the mix. So we'll also do a deep dive on that on Friday with the whiteboard. So those are two things I'd like to spend a little time to dig deeper so that you understand some finer points about DNS, because there's back-end stuff with the recursion process that has to play out. And oftentimes the implementation of a split DNS infrastructure in an enterprise environment is hobbled or crippled for lack of that knowledge and understanding by those who are implementing it. So this is going to be like a special topic / hands-on session, and the highlight's going to be DNS. And then you can stand up your own DNS server on Friday if you duplicate the same steps that Jadel took to create his virtual hard disk. If you have your virtual hard disks ready and on a thumb drive, when you come to class on Friday, we can quickly, well, actually, we can use the same VHD. Jadel, can you remind me, did we use Disk Manager to create that VHDX, or did we use the utility in VirtualBox to do that?
We use this manager.
So we use the Windows.
Because the VirtualBox had the wrong format, and you said that we need them to use VHD, so we went them to this manager and made a VHD.
Yeah, it's not that it had the wrong format, but it had its own proprietary format, VDI.
Yeah, VDI, yeah.
Okay, all right. So actually we can quickly, I'll take that back. You don't have to build your own VHD. If you would like your very own DNS server, all you have to do is bring your standard activation key and provide that to me, or just allow me to use that to stand up your system on Friday, okay? So our hands up will be for you to stand up your own DNS local with your own virtual machine with Raspberry Pi or on the virtual platforms, okay? And we're going to do a deep dive on DNS and answer the other question about GRC shield up scans that reveal other exposures on the network when unshielded port analysis is being conducted, okay?
So to clarify, we just need to provide you with the information we had pulled off of the Azure software download and bring a USB, or
yeah, it would be handy to bring a USB, because you might want to build the machine and then run it in your own home environment. But
okay.
But as long as you submitted that as a part of your assignment in module 1, all you'd have to do is send me an email in class authorizing me to use that standard license for your dedicated server. Okay? Does that make sense?
And then Yeah, and then once we come to class on Friday, we would just have to set up the virtual machine in VirtualBox using
Correct.
what is on the USB.
Actually, if you're gonna use it in your home environment, you would set it up in VirtualBox.
Mm-hmm.
And you wouldn't need the USB, but you'd want, so if you decide already you want to run it on a separate host in your home environment, then you'd probably want to use VirtualBox. Or if you have appropriate hardware, you could use the data center license. So what we'll do is walk through the different options, but unless you have a very hardy, very large, always on 24/7 host in your home environment, you're going to be running a local DNS server when your VirtualBox is running, okay, on consumer grade technology. You might have a gaming system that's a monster and it could easily do this and it's always on. So I'm not going to make any assumptions, but you could use your data center license for that purpose, or you could use your standard license for that purpose in your own home environment. But if you would like, you can just park your server on our system, and you don't have to use the standard license to do that. So if you want to run your own dedicated server, you're going to want to have that license handy, and you're going to want to choose where it's running, and depending on where it's running, you're going to want to give us permission to use your license to do that. Okay? If you
Okay.
if you decide that you're going to allow your dedicated DNS server to be hosted on one of our monster platforms in my office, then you don't have to use your activation key for that purpose. It all depends on placement, and that's something that we'll cover on Friday, okay? I'll have a quick breakout of how that works. So what you want to do in advance of Friday, let's cover that segment now. I was going to cover that at the end of class. Each of you need to decide if you would like to run your own DNS service in the home environment. So you're gonna ask that question of yourself. That's the first question to ask. Do I want to do this and try this? It means that you have to be willing to work a little maintenance or a little up. You have to run updates on a system, right? The next question is, do you want to give it a try with Raspberry Pi on a Pi hole? And would you like me to provide you with a Pi hole, right? So I will send an email out where I have these progressive questions, and before we get to the class, you need to respond back to that email so we know which implementation you want to do. So you could say, no, I don't want to do it in my home. Would you like to have dedicated DNS service for your home environment that we host at UVI? If the answer is yes, then I'm going to assume that you would prefer for us to have a system running on one of our platforms with a dedicated IP address, right? And in that case, I'll know how many virtual machines we need to be ready to stand up. The answer could be no, I don't want to do it in my home environment, and no, I don't want to do it. I don't want to depend on UVI. I'm just going to do what I'm going to do because it's complicated in my home environment, and that's fine, okay? But I need to know the answers to those questions from each of you by, say, close of business tomorrow, Thursday, okay? So I will send that.
Okay.
I will send that email at the end of our class, and all you got to do is answer the question. All right. So we've got some questions that were flagged here where nearly all the students answered correctly. For the true, false, and multiple choice, is there anybody that wants to see one of these items? I mean, just to review it. And that shouldn't say MC10, there should be a topic there, my apology. Let's look at a multiple answer question here that had a low score. So the multiple answer question posed a challenge. You must recommend router adjustments to mitigate the number of suspected exposures from multiple devices. Have you ever noticed in some assessments that you read about a scenario in another question and you're like, oh, wait a minute, if that information is true, then I answered incorrectly on the other question. It's kind of a deja vu moment. Does everybody understand what I'm talking about? Isn't that a telling statement? You must recommend router adjustments to mitigate the number of suspected exposures from multiple devices. Well, that kind of plays back into the other scenario we talked about on GRC Shields Up, right? Everybody catch that? That's a test taking skill. Sometimes you pick up like breadcrumbs and other questions, and then you're like, oh, wait a minute. And you don't want to overthink questions as a test taking skill, but you do want to be alerted to cases like this, especially on certification exams. Okay, can somebody unmute your microphone and tell me you're still with us?
Still with you.
Okay.
Yep, still here.
The latest firmware has already been downloaded and defaults applied properly. So that's an important consideration. If you don't apply the defaults after the latest firmware has been downloaded first, you'd be shocked how often the benefit of that latest firmware just doesn't engage. It just doesn't engage properly. But if you apply the defaults, you may have specialized settings. So that's a pain, and that's one reason why people, it's a finer point, but it's one reason why people do not apply defaults after they download the latest version of firmware. This is true not only for devices and systems and servers, but it's also true for things like routers, right? After the defaults have been applied to the firmware or BIOS, I'm talking mostly about BIOS, right? System code. Then you go back and you make sure that if you have custom configurations, you know, those are retained, or you reconfigure those custom settings. Sometimes when you apply defaults, those custom settings are undone. But it's one of those necessary evils. So yeah, that's just a finer point after 25 years of working on this stuff in the trenches. What additional measures are recommended to address the primary concern? Okay. Configure guest Wi-Fi. This is the first and strongest recommendation. If there are any of you that do not have guest Wi-Fi configured in your home environment already, you need to do it now. Because when other people come to visit, they're going to bring little nasties, and then those little nasties are going to jump the fence and get on your devices. And this is one of those primary things you need to do. If you disable TCP/IP version 6, then you eliminate the prospect of something called tunneling. So oftentimes smart devices or connected devices in your home, which are it's not mobile technology where there's a processor and multiple user accounts and so on, right? I'm not talking about a tablet or a laptop or a PC or a gaming console. I'm talking about things like video cameras, wireless video cameras, wireless door locks, integrated smart appliances and outlets where you can control things, you know, home automation types of things, right? Those are the types of connected devices that if they can hop onto IPv6, they don't have a way to go. They'll use the tunneling protocol, and that tunneling protocol, it creates all sorts of problems. Many students answered configure quality of service. Now that helps with performance. the reason that's not an answer is because quality of service has more to do with performance adjustments, not so much security exposures. So that was a bogus answer for that reason, okay? Let's look at the other possible answer, create custom routes. Creating a custom route would help with specific traffic, but not, it wouldn't be likely to reduce the exposures that other devices on a home network are generating. The same is also true of port forwarding. Although I'd like to know if those who answered disable port forwarding, if you have a rationale for that answer, I would consider giving you credit just for a case-by-case exception. Because most often when you disable port forwarding, that if you have proper, let's put it this way, if you properly configure port forwarding, it's not going to add to your exposure. All right. So you're not going to have Swiss cheese on a GRC screen if port forwarding is correctly configured on a socket level to a specific device out on the internet, a fixed IP address. So if port forwarding is done correctly, it's not going to be a source of exposure. However, if you're one of the 2 students that answered disable port forwarding and you send me an email that says, hey, I'd like additional credit, here's why I put it. If your rationale is sound, we can share that with the class on Friday in kind of a value added segment, right? And I will post additional credit for your score. So just thought I would offer that. Any questions? All right, let's look at this multiple answer question, because this would be the last item that would pose the greatest, oh, and there was a mistake on this one here, the matching. So these 2 are the last ones that we'll review. So please match the desired interest with the command that provides this output. If you want the MAC address on a local host, ipconfig will give that to you. If you want MAC addresses on LAN connected clients, Nmap with the right options will provide your MAC address, okay? So Nmap is the answer that's needed right here. Public IP address, firewall status for designated port servers, server ports. That's what we say designated server ports. We're talking about ports 0 through 1053 or 54. That's the shields up display. So that's the answer here. Sockets for established connections. That would be netstat dash A, and then running app or service for established IP connections would be netstat dash B. Any questions about the matching? Okay, last item would be multiple answer. TCP ports 135, 130, yeah, this was a complex scenario. So let's take in the scenario first, and then we'll review the questions. TCP ports 135, 139, and 445 are part of the sockets listed for a scan on a powerful gaming hacking laptop sporting several high-performance connectivity options. The active Wi-Fi interface on the laptop has already been configured to disable NetBIOS over TCP/IP, yet the ports of concern remain exposed despite this change. So the live active connection already eliminates NetBIOS over TCP/IP, yet we're still seeing these exposures, right? Additional information. A service router is configured with the DMZ option to support the use of a dedicated gaming platform to serve as the host for several multiplayer games. The dedicated gaming platform does not have a simple option to adjust ports and services. So all it does is it's got a DMZ option. It says, here's my gaming console, my gaming server, or here's my web server, and that's it. Okay, select the best options below to address this persistent exposure. Well, we have discovered that other network interfaces can be in the mix and they are not disabled. So on that same laptop, you could have an Ethernet, an unused Ethernet interface, right? You would disable on virtual machines. If it's a powerful gaming hacking laptop, the odds are pretty good. There are virtual machines like Kali or Mint or whatever. So when you see the word hacking, that's a hint that is intended to imply that there could be virtual machines like Kali in the mix. Okay. So remember, you get to retake this assessment. Just remember that we're going to post a retake and you're going to get another attempt at this. So my apologies if that wasn't readily apparent, but that's why we're walking through the items on the item analysis right now. Okay. Everybody with me? Can somebody unmute your mic?
Yeah, I'm with you.
Okay. All right. So the first order of business is to find the other physical network interfaces on that monster laptop and disable the NetBIOS over TCP on those, even though they may not be currently in use at the time. The other thing is to disable the NetBIOS over TCP/IP on virtual interfaces for virtual machines. That's another common source of that kind of thing. And then here's the last one. Because you're working a DMZ option and because of the application, what you want to do is allow for selective changes as needed with your local security. If you create custom firewall rules to block the exposures here, but then allow the gaming ports that are used, this would be a really solid way to address that issue. So if you have other exposures on the firewall or on other devices there may be other devices on your local network, and those other devices on your local network don't have the option to turn on or turn off NetBIOS, right? So if they're designed to run on a legacy network, a good example of this would be an old wireless printer. Do any of you have wireless printers you've had for more than a year or two in your home? Anyone? Wireless
Yes.
printers? Yes.
Yep.
Yep. And those older wireless printers are designed to accept print requests from a variety of clients, right? Older PCs, older laptops. So a lot of times those older printers, they have a simple console to adjust things, right? They don't really have an interface where you can get into the weeds on network configurations. You can configure the IP address and the subnet mask and the gateway, but most of those printers don't have a sophisticated enough network interface to allow you to adjust, oh yeah, let's disable IPv6. Oh yeah, let's disable NetBIOS over TCP/IP. So it's those older wireless devices that can really cause problems. So you create the firewall rules to block those exposures, but you have a game console, and you don't want to be the guy that can't host the game for your multiplayer network game because, well, there's too much exposure. So you create a custom firewall rule to allow the gaming ports. Does that make sense? Does everybody understand?
Yes, I do.
Okay. So I think the reconciliation is already posted. Before the end of the week, we will post the alternate version of the Module 1 assessment for your retake. Please complete your reconciliations and submit them at this time. Okay. Also, for module 2, I thought I would share with you that in module 2, we'll be getting into network landscape. So we're going to take a deeper dive into different types of networks. We're not going to spend as much time on that as we did in module 1. So it's going to be a faster pace. There's going to be more material. In particular, you're going to be reading chapters 1 and 3. Once again, we're going to summarize the concepts out of chapter 1 and chapter 3 for network landscapes. When we talk about host-side artifacts, we're talking about the types of, we're going to talk about the environments, and then so this first chapter is really going to be a blitz, right? We're not going to spend a lot of time. We're just going to review evidence handling, verification, and that kind of stuff. That's just a refresher. Very short amount of time spent on chapter 1, but we will hold you responsible for knowing the content of chapter 1. We're going to spend most of our time in the network environment, right? Particular how connected hosts in that environment will present. So we'll talk about how the network is staged and then how those hosts look in that environment when connected to that specific type of environment. What we're saying is that you can take the same device or system and connect it to a home network, and it's going to appear in some ways and behave in some ways a bit differently than the same device that would be connected in a business class environment, where there's business grade Wi-Fi and enterprise networking and segmented networks. That same device connected in that different environment will present differences in behavior and attributes. The attributes of the host may differ depending on the nature of the network environment. So that's why we've decided to frame our second module about the network landscape. We'll take into account the client side and the network environment side. And then we'll talk about what you do with the evidence when you're looking at that and you discover something. Did everybody catch that description? So we have different flavors of networks. We have different clients in those networks. Some of them are mobile and can be connected in both of those different environments. The artifacts that present can differ based on the attributes of the network environment and what connection methods are used when those clients are in the mix, right? Once we account for how that dynamic works, you're going to come across and discover evidence. So we want to talk about the artifacts and what you do to preserve that evidence, and that's how we kind of bring it all together in our second module, all right? By the time we get closer to Halloween, you're going to be doing capturing of network data. So this is just a preview of coming attractions. But we are going to be finished with module 2 content by the time we get into the midterm exam, okay? Any questions before we close today? All right, please keep your eyes peeled for that email with the questions, and we'll see you Friday.